When you think about looking inside your own body, you may only be able to picture images like this or this. But an emerging technique gives us pictures that look more like this, using laser-induced sound waves. Early technologies that use this technique seem to provide us with highly detailed, super clear images of the structures inside our bodies, with no discomfort or dangerous ionizing radiation involved. And this promising technique is called photoacoustic imaging. A basic breakdown goes like this. Different biological materials have different chemical structures. The hemoglobin in your blood, for example, is chemically different from the calcium in your bones. And this means that they're able to absorb different amounts of energy. Photoacoustic imaging takes advantage of these differences in composition by tuning laser light to the wavelength that can be absorbed by the tissue you want to look at. So an apparatus sends tuned pulses of laser light to a specimen or body part, and the tissue that can absorb that wavelength of light absorbs that energy and heats up. And when the tissue heats up, it expands ever so slightly. That expansion and then rapid cooling generates a wave of oscillating pressure in the surrounding material, the rest of your body or the air, which is, in the simplest possible interpretation, a sound wave. That's the acoustic part of the name, giving us photoacoustic imaging. Then, ultrasonic detectors capture these microscopic changes in pressure, and processing software reconstructs an image based on what those sensors hear. It's pretty different from other current imaging technologies. CT scans and X-rays and PET scans use damaging ionizing radiation to see inside your body, so we want to limit how many times we expose someone to that radiation. An MRI involves an extremely strong magnetic field, which can be a problem for anyone with any kind of metal implants, and they often take many minutes to form an image. And even ultrasounds, which also use sound waves, actually aren't as clear as this newer option. Ultrasounds are more of a catch-all. You can see everything, all the tissues in a specific area, whereas with photoacoustic imaging, you can pick and choose what you want to see just by tuning the wavelength of the laser beam. And while this technique is only just starting to be clinically explored as an alternative to more traditional imaging, and prototype clinical machinery is just now being developed, the idea has actually been around for more than a century. Alexander Graham Bell, the guy who invented the telephone, was the first to observe that electromagnetic waves could induce sound waves when applied to materials. But the technology that's just started to emerge and be refined in the last decade takes that initial observation and makes it into something that could seriously revolutionize medicine. Imaging veins and arteries this way, for example, can tell us more than ever before about changes in someone's circulation or abnormalities in blood flow related to cardiovascular disease. We can see how tissues are faring after surgeries. We can see what kind of effect a drug is having. The applications are really kind of stunning when you start to think about them all. Because not only can this technology be used to image tissues at extremely high resolution, you can also introduce a foreign material, like a contrast dye or a specifically designed nanoparticle, to see things you might not be able to otherwise. These substances can be tailor-made to bind to certain kinds of cancer cells or other forms of gene expression. And then you can tune the laser to the wavelength absorbed by that contrast or that nanoparticle, giving you an extremely detailed and accurate picture of how a disease manifests in your body. And I guarantee you're not ready for what's maybe the coolest part. There are several companies that are making versions of this technology that's highly portable, and are designing software that uses machine learning to identify different structures on the image for the user. Both of these developments means it's possible that some patients could use this technology themselves to monitor their own health and things like progress during recovery from a condition or a surgery. Technologies like this are an exciting look at how we're improving our understanding of our own bodies and the way we can look at and treat them. I love how physics and engineering and computer science and medicine are all coming together to make this happen. And I think it's a great example of how big leaps in science are, by necessity, cross-disciplinary collaborations that, by the sound of it, will continue to improve lives all over the world. If you want even more on new and improved ways that we can monitor our own health, check out this video here, and make sure you subscribe to Seeker for all your medical innovation news. If you have another emerging medical technology you'd like to see us cover, let us know down in the comments. And as always, thank you so much for watching, and we'll see you next time.